Hey everyone, welcome back. So in our last explainer, we really nailed down the essentials. Today, we're going to go a level deeper. We're actually stepping inside the world of DevOps to see exactly how modern software gets made and delivered to you. So this is the big question, right? It almost feels like magic, but I promise you, it's not. The secret is to stop thinking about it as a bunch of disconnected commands and instead see the whole thing as a modern automated factory, a software assembly line, really. And that's what we're going to do today. We're going to build that picture, slide by slide. So grab your virtual hard hats and let's head down to the factory floor. Okay, here it is, the floor plan for our entire factory. It all kicks off when a developer commits their code. That's basically the blueprint. From there, the blueprint zips over to the assembly line, where it gets built and put through a whole battery of tests. Once a part is assembled and passes inspection, it's stored in a warehouse as something we call an artifact. And finally, the last step, it's shipped out to the customer. We call that deployment. This whole automated process from start to finish, that's our CI/CD pipeline, which stands for continuous integration and continuous delivery. Now, this is where it gets really cool, the idea of traceability. Every single blueprint, every tiny code change gets a unique fingerprint. We call it a commit hash. Think of it like a serial number stamped on a part. When we build our software, we literally tag the final product, the container, with this exact hash. Now, why do we do this? Well, it creates a perfect, unbroken audit trail. If something ever breaks out in the real world, we can look at the running container, find its tag, and trace it all the way back to the exact line of code that caused the problem. So remember this. In this world, traceability is everything. Okay, so our assembly line just cranked out a brand new, shiny software component, our artifact. We can't just, leave it lying around on the factory floor. We need a safe, organized place to store it before it's ready to be shipped. So where does the warehouse fit into our factory? Well, you could just toss all your finished parts into a generic storage bucket, something like cloud storage. But that's kind of like piling everything up in a big open field. I mean, it works, but it gets messy fast. The professional way to do it is to use a specialized warehouse. And in the cloud, that's a tool like Artifact Registry. It is purpose-built for exactly this job. And this slide really shows you why that matters so much. See, Artifact Registry isn't just a garage for your container images. It's a highly organized, massive warehouse for all of your software parts. We're talking code libraries for different programming languages, like NPM for JavaScript or Maven for Java. It gives you really fine-grained security, meaning you control exactly who has the keys to which aisle. And maybe most importantly, it becomes the single source of truth. Everyone in your company knows this is the place to get the official, approved, ready-to-go components, no questions asked. All right, let's throw a wrench in the works. Let's add a big security challenge. A lot of organizations, especially in fields like finance or healthcare, have a super strict rule. Their factory's assembly line cannot have any connection to the public internet. No outside parts allowed, no open doors, nothing. So how in the world do you build software in a completely sealed-off environment? Well, the answer is something called a cloud build private pool. This is your top secret clean room. It's a build environment that exists entirely inside your own private network with absolutely zero access to the public internet. This whole setup prevents any kind of external contamination or security threats from sneaking into your software supply chain. And it's an absolute must-have if you need to deploy your final product to a private GKE cluster, which is just a secure, managed environment for running your applications on Google Cloud. So, we've built our component, and we've done it securely. Now it's time for quality control. A really common mistake people make is to just run every single test they can think of all the time. But a smart factory doesn't work that way. An effective testing strategy is all about sequence and purpose. It's about running the right tests at the right stage of the assembly line. And this is what that best practice flow looks like. First up, in the development environment, you run what are called integration tests. These basically ask, hey, do all these new parts we just made actually fit together correctly? Once that passes, you move on to staging. Here you run load tests. This asks a different question. Can our finished product handle real-world stress before we ship it out to customers? And finally, after you deploy to production, you run a quick smoke test. This is super simple. It just asks, is the power on? Does the most basic stuff still work? This whole structured gauntlet ensures you have a quality product without just wasting time and resources. All right, the moment of truth. Our artifact has passed all the tests. It's ready for the customer. Now, this is the most critical moment of the whole process, deployment. The big challenge here is getting the new version out to your users without causing any downtime, any errors, basically without any drama. So how do the pros handle this delicate operation? This table breaks down the key trade-offs perfectly. First, you have a rolling update. It's fast, but it carries a medium amount of risk. You're basically replacing old servers with new ones one by one, kind of like swapping out products on a store shelf. For a little while, both the old and new versions are running. Then there's blue/green deployment. This is much lower risk. You build a completely new identical environment, that's the green one, and once you know it's perfect, you just flip a switch and all the traffic goes from the old blue one to the new one. It's like swapping out an entire storefront display all at once. And finally, you've got canary deployment. This is by far the safest, but it's also the slowest. You release the new version to a tiny fraction of your users, like 1%, and you watch it like a hawk. If everything looks good, you slowly dial it up. It's exactly like giving a new food sample to just a few shoppers first before you roll it out to the whole store. So let's wrap up our tour of the software factory. The big takeaways are: always think of your CI/CD pipeline as that automated assembly line. Use a specialized tool like Artifact Registry as your central warehouse. When security is critical, build inside a clean room using private pools. And finally, ship your product to your customers smartly, choosing a deployment strategy like blue/green or canary that balances the speed you need with the risk you're willing to take. So we've built this incredible, efficient factory. Your code can now travel from just an idea all the way to a user automatically. But the work of getting better is never really done, is it? So the question I want to leave you with is this. Now that you've automated the build and delivery, where's the next bottleneck in your process? Let me know what you think. Thanks for joining me on this tour.